Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solving systems of equations. This is standard A.5C in the great state of Texas, and we are using item number 5 off the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we're looking for a solution to the system of equations. That means that we are sharing x and y values. Now, we've got two different answer choices, A and B, that give us an x and y coordinate. But C and D, let's look what these two would mean real quick. There is no solution. Okay, so what would that look like if there were no solution? Well, a solution is when they intersect. All right, so when they intersect, that means that, there's going to be one point in which the two lines, as long as they're both lines, they're not, quadratics or anything like that. So if there was no solution, that would actually mean they're parallel. They never get any closer, they never get any farther, so that means that they don't intersect, so that means they would parallel, okay? So maybe these are parallel lines. Or there is an infinite number of solutions. What does that mean? Well, that means is actually just the exact same line. Every single point, I'm going to draw the same thing right on top of it. Every single point is exactly the same. So those are our two options for C and D. They're either parallel or they have the exact same line. How do we know that they're parallel? Right? Well, we would look at the slope. We're going to see that for both of them, right? You need an equal slope. The difference here would be on C, if there was no solution, you would have just a different y-intercept. It would be a little bit higher, a little bit lower. Same line, exact same, y-intercept, exact same slope. So how do we figure this out? Well, we've got two different choices. We've got substitution and elimination, and it looks like they've lined it up for us so that elimination works best for us. So what that means is I want to take these two equations here, and I want to add them together and eliminate one of the variables. And I'm seeing right here, watch what happens if I multiply the top and bottom, or the top equation by 2 on either side. I'm going to do that right here. So 2x plus y. I'm really looking at that y, because I've got a positive y and a negative y right here. And so that's really what I'm going for right there. So let me just rewrite that down. I'm going to distribute this out. So that's going to end up being 4x plus 2y equals 80, right? So if I were to graph this equation right here, the original one, and then this one, these two would be parallel lines. Or these two would be intersecting lines, excuse me. There'd be an infinite number of solutions because it's the exact same line. I just doubled it. Now, let me get the second line underneath this and watch what happens. Now I can add these two. Because if I add these two, 4x plus x equals 5x. That's what elimination does. But look at this. I've got plus 2y minus 2y. That's what I'm wanting. I'm eliminating a variable. 80 plus negative 20, that's 60. So it looks like if I divide both sides by 5, right, x is going to equal 12. Okay, so it looks like I've got an option right there. I think the y is 16, but rather than just guess, let's go ahead and plug x in, right, and we can plug it into either one. Let's go ahead and just plug it into that second one right there. So instead of x minus 2y, I'm going to write 12 minus 2y equals negative 20. So now I'm just going to solve for y. So I'm going to subtract 12 from both sides. And that's going to be negative 2y equals negative 32. And let's divide both sides by negative 2. Y is going to equal 16, which is exactly what I was wanting. If I were to plug this 12 into the original equation, the original top one right here, I would also get y equals 16. And that is my answer. A.